Welcome to Ask and Learn.
In this video, we are going to show that any finite non-empty poset has a maximal element. So we will represent our poset as S and this sign for the relation. And being maximal element means that element A, if there is something that is greater than A, then greater or equal to A, then it must be A itself. So we cannot have a different element that is greater than A. Okay. Now I will prove this using contradiction argument. It can be proven in other ways as well, but in this video I will suppose the opposite and then show that it leads to contradiction. So suppose that there exists some poset, finite non-empty poset, such that it has no maximal element. So since S is non-empty, there must be at least one element in there first. So call it X. Then since X is not maximal by our assumption, there must be another element. I will call it X1, which is different from X, and such that X1 is greater than X. Alright, I write just strictly greater to emphasize that they are not equal. And so we have X1 in S. What's important is that X1 has to be in S as well. Okay, moving on. Similarly then, since X1 is not maximal either, we must have X2, another element inside S that is greater than X1. And we can keep doing this with X2, X3, and so on, right? So you can see that we have construct a strictly increasing infinite sequence that is X1, X2, X3, and so on. And they are all different by the way we construct it. And they have to keep, like, the sequence must go on forever because if it stops somewhere, then it means S has maximal element, right? That point that they stop will be maximal. And so we have infinite sequence inside S, but that in itself is a contradiction because we assume that S is finite. Not assume, we have the condition that S is finite from the start. All right, so the assumption here that such poset exists is wrong because it leads to a contradiction. That is the proof of this statement. So yeah, that is it for this video. Thank you.